Okay, we're now live. What's up, everybody? This is Brigantix here, back with another video. Today we're gonna be showcasing something I've been working on for a couple days now. This is the start of a computer that I'm building, like a functional computer in Minecraft, and I'm gonna be updating you every time I make like a significant contribution to it, basically. Um, See, I made a take a couple like an hour ago. I thought it was all fine until it was super skippy, so my computer isn't the best. So I just changed a bit of settings and we should be good now. So this is the ALU, or the arithmetic logic unit. This is the first part of the computer. And by reading the title, it's obvious that it does math, or arithmetic, and logic. But so first, before we get into the things, I need to explain to you about binary. Now, if you don't quite get this explanation, I'll link a video, or yeah, video about how binary works. So basically, in our counting system, we have it's called base 10. So basically, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers until we have to start over again and with 0 and add a number between it. So this is 10. If we keep going like that, we hit 20, then 30, then 40, and so on. See, binary is kind of like that. It's base 2. So in electricity, it can only have two states, off and on. So the off can be like a 0 and the on can be a 1. So what we can do is something called binary. So we have 0, 1. We can't show another number here, so we move on to the second bit. This is 2. Then you add another one. That's 3. Add the third bit, which is 4. 5, 6, 7, and then 8. So it just kind of keeps going on until we get to the 8th bit. So you've heard of 8-bit games. So basically what an 8-bit machine is like it has 8 lines, it can hold up to 8 lines of like binary, and the biggest number that you can hold with all of these numbers here, if I can do that, is 255. So it can our modern day computers are like 64-bit. So it's got like 64 binary lines, which is like getting into like the quintillions, or like that's a like unimaginably unimaginably huge numbers. Um yeah, so if you didn't get that explanation, you can watch the video I put down in the description. So this um the first function that I'm going to show you is the add function. So basically what all you need to do is flick the sum output. So whatever the two inputs, you have the A input and the B input. They go into here, and this part adds them together into like, and sends it out here for the output. So let's put in a number, any number. Let's do 5. See, this is 4 plus 1, which is 5. 5 plus 3, 2 and 1 is 3. And as we look up here, we can see that this is the fourth bit. For the fourth bit is 8. So 5 plus 3 is 8. So we can see that it um did that calculation correctly. Let's add this lever. So this is 7 plus 3 and it shows 10. So 8 plus 2, 8 and 2 is 10. All right. Let's do something a bit more complicated here. Alright, we're gonna do subtraction. So what you need to do is invert the A. So basically what this does is whatever comes in, um, the opposite will come out basically. And the carry-in just adds 1 to it. So, and you also have the sum out, the sum. Alright, so let's do, and also one thing to note, the bigger numbers have to go on top. They can, you can't have a smaller one and a bigger one here, or like negative numbers will come out and it's pretty confusing. Let's do 12 plus 4. See, there's a 12 and 4. And 8 comes out. So this is 8 in binary, so it did the job correctly. Let's do 12 minus 6. You get the 6. So that's subtraction there. And you can you can do the same thing with inverting the B. I haven't put up all the signs here, but I'll do that next time. So what this has the smaller number has to go up here now. So let's do what's this? 5 minus 3. Wait. 5 minus 3. Did I do that correct? Alright. I don't think that works right now. Well, I think you can only do subtraction with the invert A thing. Alright, let's look at another function that this ALU has. Let's turn off all these peppers. Let's do the AND output thing. This is the AND, so this is logic. We're getting into logic now. So let's just flick a bunch of levers randomly. Let's there, do, few, dang it, there. Alright, so there. So what the AND function does is it takes a look at the two inputs. See, it checks if both the inputs on the one bit are on. If so, these two are both not on, so the output will be 0. But these two are on, so it will output a 1. Same thing with this one there, and another here. So that's what the AND function does. Let's look at the next function, which is the exclusive or XOR. What this does is checks if the inputs are different. So these two are different, off, on, so it's gonna be a 1. These two are both on, so that means they're the same, so it will not be on. These two are off, and they are the same, so it will be off. These two are also the same, so, and these three are all different, so it will give an output. Alright, so let's take a look at the next function. So you need the XOR and the AND function both on at the same time for this. So this is the OR function. So what this does is it takes a look at both inputs, and if any of the inputs are on, it will output it. So like this bit is these two bit are on, so it's on. These so no these not the A input and the B input are both off. So there's an off at the output is off there. But if we turn one on, then it will turn on. So that's what that function does. It's the for function. All right, let's do let's do another thing. We're gonna look at the shift functions. All right, so let's input a number. Let's do, what's this number? Um, let's 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 do this one. So this is 15 binary. So, all right, so we need the sum output on for this one. So just this 15 goes in through there. This is this divides it by 2. So it shifts right. It shifts the bits right. So if I flick the lever, it'll shift over right. So this isn't like exact. This isn't this is not exact like division, but you can see it's kind of like it. So you have 15 divided by 2 is around 7. So it's not like exact division, but it's and this is the multiply thing. So it shifts it over to the left. So you'll have 15 times 2 is alright, so 16 plus 8 plus 4 plus 2 um which is 30. So like the multiplying it actually multiplies it by 2 basically. The This one isn't like exact, but this one is like actually multiplying, if that makes any sense. Um that's all I have to show you right now. Pretty soon when I'll make a video, like an update video, when I make the add other stuff to it so it will function like an actual computer. Because right now it's basically like a fancy calculator right now. It cannot. You have to put in the inputs by itself. You can't run any programs on it yet. It's like a calculator. But pretty soon, it will have its own memory, so you can put the data in the memory, and it'll have like a bunch of stuff where it'll um input the functions for us, so it will run like an actual computer. And pretty soon, like once it's completely done, it'll have like a screen, have a bunch of RAM or like long-term memory, and yeah, it's gonna be pretty cool. It should be able to run like Pong, run programs like word processing, math, complicated math. So yeah, I hope you enjoyed this little video. Um, Something I'm working on. I hope you, if you want to see more, please like and subscribe and click the notification bell. And I'll see you next time. Bye. Alright, there.